Hey guys, so you just learned that in standard form, you really can't see the vertex like you could when you had vertex form. So, how do we find the vertex when you have standard form of a quadratic function? First, you need to identify what a, b, and c are. Once you have those three values, to find the h coordinate of the vertex, you have to compute negative b over 2a. Notice how for this expression, the b and the a will come directly from your a and b values that you identify in step 1. Once you find that, then you're going to plug in whatever number you just found for h that came out of this little expression, plug it back into the original equation, then find the k value. At that point, you have your vertex, or you have your position. Then to graph, as before, you make a table where you'll put the vertex in the middle, and you'll find 2 additional points that you can then reflect over the mirror and have your graph. That's a lot to look at, guys, with words. Let's try an example of how that works. So first, let's just practice finding the vertex. So back to step 1. Identify a, b, and c. So in this case, this is standard form. A is going to be the coefficient here, which is 1. So here a is 1, b is 4, and c is negative 3. That's step 1 in this process. Step 2, you're going to take this negative b over 2a. So negative b over 2a. And you're going to compute this. So guys, I urge you to write that down every time and then change every variable to a parentheses. So negative b over 2a. And simply input the b value in here and the a value in there. So negative b happens to be 4 here, so I'll drop the 4 in this parentheses. And then over 2 times a. Well, a here is positive 1, so I'll put that in that place. And then I just work this out. A negative times 4 is negative 4. So I get negative 4 in the numerator. And then 2 times 1 is simply 2 for my denominator. And if I simplify this, negative 4 divided by 2 is negative 2. So I quickly found that h is negative 2. So for my vertex, I now know that h is negative 2. That's what I compute first with this expression. So I can fill in half of my vertex already. Guys, and at that point, I know some other facts. We learned before that once you find the h value, this will always represent your line of symmetry. So once you find that, you already know that it's going to be at x is negative 2. That's going to be your mirror when you graph this parabola. Guys, additionally, you already have a from the beginning also. So here a equals to 1, so I can fill that in as well. And if a is 1, then we know our shape's going to be opening up like that, and we can have a minimum in this graph. So do you see how just finding those couple of variables, we have a lot of characteristics about our parabola already. But to finish finding the vertex, once you find the h value, step 3 says then to plug in what you just found back into the original quadratic equation. In this case, it's x squared plus 4x minus 3. So I'm going to take the original equation, I'm going to copy it, but I'm going to replace every x with parentheses. So x squared will be as follows. X squared plus 4x, so I'll put plus 4 and then skip the x for parentheses, and then minus 3. So I'm simply copying what's already there. And I'm going to input what I just found for h back into these 2 open parentheses. So I'm going to input a negative 2 into each of these parentheses. And when I do this work, what I get here as a result will be my k value. So negative 2 quantity squared means I have 2 of these. So negative 2 times negative 2 is positive 4. And then 4 times negative 2, this will be negative 8. Then we have a minus 3. If I add these together then, I end up getting negative 7. Again, if you need a calculator, use that please. So here I now find that k is negative 7. So I now have my complete vertex of negative 2 and negative 7. Again, the goal for these notes here is that we can find the vertex given a quadratic in standard form, because it won't give it to us in the very beginning. Here we get a, b, and c, but we now have a way to find the vertex by using negative b over 2a, and then following this process.